Hey, what's up, everybody? It's Mr. A, and we're back today talking about the second part of section 12.2, which deals with combinations. So let's take a look at the word combinations, and of course, I don't have exactly the smallest belly in the world, so when I think combinations, I'm thinking, our favorite golden arches, right? And when you think of a combination meal, like you order a Big Mac combo, and let's say you order that combo, does it matter how they put it on the tray when they give it to you? For example, do they have to put the burger first and then the soda and then the fries? No, probably not. And if it bothers you that much that they do that, then you probably got issues that you got to deal with, right? You know what I'm saying? Like, you're not supposed to put the soda first. So if that's you at McDonald's, then we got a couple problems you need to deal with, but that's all right. So what we can tell from the word combinations is that the order that they put it on the plate doesn't matter. And that tells us something about combinations, which is that order does not matter. Different from permutations where order does matter. Combinations, they don't want to know the order in which like the runners finish. They just want to know how many different groupings you can make. So for example, let's say that we were sitting in class and, the yearbook people came by, they said, this is the smartest math class ever, and we want to interview these kids to see what they're doing that makes them so smart, so please send them out 3 kids at a time. Okay, well, if I send them out 3 kids at a time, and those 3 kids come back in the interview, it wouldn't make sense for me to send those same 3 kids back out, but in a different order, right? Because order really doesn't matter there. They just want 3 kids at a time and get them interviewed. And that's different than saying how many ways can in this class can I have the top 3 finishers ranked by grade. There, of course, order matters. So that's not a combination. That would be a permutation like we talked about last section. So here is the formula for combinations. Go ahead and maybe press pause, write that down. It looks a lot like the formula for permutations. In fact, if you look, the formula for permutations is right here. Okay, but what we're doing when we add in that extra r factorial on the bottom is we're accounting for all the extra iterations that happen when I count order as mattering, like in permutations, and I get rid of all those extra by dividing by r factorial. So for example, when I send 3 kids out at a time, like in that interview example, well, 3 kids at a time, there are 6 different ways that I could arrange those 3 kids. But if order doesn't matter, then I need to divide by that number 6 or that 3 factorial to show that order doesn't matter, and I need to take away all those extra examples that I made of putting kids in order. And remember, this is an important one. N is the total number of objects to choose from. That's going to be important in this section, finding out what our N is. Here's an example like 18 to 25. All that they want you to do here is remember that 15 is your N and R is your 7. So we're going to take this and plug it into the formula given, which is 15 factorial over, 15 take away 7 is going to give you 8 factorial, and then R factorial, that's just 7 factorial. So you can put that in a calculator. We've done that in class, shown how you can do that NCR function. So if I do 15 NCR 7, 15 choose 7, I'm just going to get 6,435. Okay, I don't expect you to write these out by hand. So now let's take a look at those runners that we looked at last section. So you can see a little picture of my car there. Didn't have much time to clean it up, but it's a little toy I have. I like it. So let's say that the runners got tired and decided to drive the rest of the way, right? They're tired of running, so a car pulls up and there's 3 seats available. Well, how many different combinations of runners could I fit in the car? Now here, if you think about it, order does not matter. It doesn't matter who gets in the car first or doesn't. Now you might be thinking that you'd be the one calling shotgun, but still order really doesn't matter of how they get in the car. So since order doesn't matter, we're going to do C. And we're going to choose 3, right? We're choosing 3 runners. Well, what is our N? Like how many are we choosing from? That was 9. So if I do 9 choose 3 on the calculator, then that gets me 84. there are 84 different ways that I could put those runners in the car. Now, let's say that we want to say, well, it does matter how they get in the car. Just for example's sake, well, maybe we won't do that. We'll save that for another slide. So you can see right there, 9, choose 3 for combinations. There's 84 different groups of 3 that I could fit in that car out of those 9 runners. Okay, now let's talk about cards. For some of you unfamiliar with cards, here's a standard 52 card deck. These cards up here, King, Queen, Jack, are considered face cards. And if you count, there are 12 face cards. Then the number cards, 10 to 2, for each suit, heart, diamond, clubs, and spades. There are 4 suits, 2 red, 2 black. And for each suit, it looks like we've got 1, 2, 3, 4, 5. There are 9 number cards. So 9 times 4, that gives me 36 number cards. And then here on the bottom, I've just got 4 aces. Okay? So what I want you to understand when we're talking about these number problems is that when they say flush, like they want a straight flush, the flush part means that they want them all from the same suit. If they say one of a kind, then what it means, the one of a kind portion means that they just want all of the same card, like all queens or all jacks or all eights. Just an example of what some of the face cards look like. Not sure what this guy's doing here. He's stabbing himself in the back of the head. So that's kind of weird, but whatever. And just another example of a face card, what a face card looks like. So let's see, how many face cards, how many 5-card hands could we have if I wanted 5 face cards? Well, in like poker or blackjack, it doesn't really matter the order that you're holding the cards. It just matters that you have them. So like the order that we pick up an ace and a king doesn't matter. It's just at the end, what do we have in our hands? So that means we're going to use C for combination. So I'm going to choose 5 cards, but how many am I pulling from? Remember I said that N was a big deal. Well, if I just want 5 face cards, I'm not going to pull from all 52 cards. I'm just pulling from the face cards, of which there are 12. Think about that. I only want to pull from the face cards. I don't want to pull from all 52, because then I'm including a bunch of combinations that include number cards or aces that I don't want. So if I put in 12, choose 5, then my answer is there are 792 different hands. Now, just for argument's sake, let's say that I was choosing 5 cards from all 52, which includes number cards, aces, everything. If I do 52, choose 5, then that's a really big number. 2, 5, 9, 8, 960. There's almost 2.6 million combinations, which is a pretty big number. And there's only 792 combinations that involve face cards. So as you can see, it's like a very slim chance that you'd get all face cards. Let's say you wanted 1 king and 4 other cards. Well, what's the important word here that we see that we studied in this section? Is the word and. That means multiplication. So if I'm going to choose 1 king, well, what's my n? In other words, how many kings are there to choose from? There are 4. And if there's 4 other cards, I'm going to choose 4. But the rest, meaning non-kings, there are 48 non-kings. So if I were to do 4, choose 1, of which there are 4 ways that can happen, and multiply by 48, choose 4, then that gives me 778,320 different ways that can happen. Now 5 number cards, same thing. I'm going to choose 5, but from the number cards, of which how many are there? There are 36. So again, that n is really important. So I'm going to do 36, and we'll do choose 5. And this way there are 376,992 ways that can happen. So it's not like I want you to memorize like how you pick all this card stuff. I just want you to know how to pick that n. That's a really important thing. Now let's look at yard sales. Try to get this one done really quick. Well, in yard sales, it says I want to go to at least 4. So there's 4 or 5 or 6 that I can go to if there's at least 4 out of a total of 6. And if I'm going to 4 or 5 or 6, that means addition, right? Or is add. So if I'm choosing to go to 4, that's out of a total of 6. Or if I'm choosing to go to 5, that's out of a total of 6. Or I choose to go to 6 out of a total of 6. And if you do that work in your calculator really quickly, you'll see that there's 15 ways to do 4 yard sales. There are 6 ways to do 5. And there's 1 way to do, obviously there's only 1 way to go to all 6 of them. So add that up, and there's 22 different ways this can happen.